Okay, in chapter 5, we're going to talk about mainly about logarithms and logarithmic functions. But in section 5.1, we need to be familiar with function composition, along with a couple of other things that we need to be familiar with as well before we jump right into function logarithmic functions. So definition, let f and g be functions. And the composite function denoted by f compose g is denoted by f compose g of x equals f of g of x. So we are basically plugging one function into another and then simplifying with function composition. So for example, suppose f of x is x squared minus 3x and g of x is 2x plus 1. F compose g of x. By definition, that means I'm computing f of g of x. G of x is 2x plus 1. So I need to replace x with g of x. 2x plus 1 squared minus 3 times 2x plus 1. And when I simplify that, I get 2x plus 1 squared means I've got 4x squared plus 4x plus 1, and then minus 3 times 2x plus 1 is minus 6x minus 3. Combine my like terms, 4x squared minus 2x minus 2. Okay? Like any other function, I can plug in numbers and I can get output and things like that. So if I compute f compose g of 3, that means that I compute f compose g of 3, and well, g of 3 is equal to 7. So I need to find f of 7. Okay, is what this question is asking me to do. So here's f of x. F of 7 squared is 49, minus 21 is 28. Okay, now also I can plug 3 directly into my function that I've computed here. And if I do that, f compose g of 3 is 4 times 3 squared, which is 9 times 4 is 36, minus 2 times 3 is 6, minus 6 is 30, minus 2 is 28. So it doesn't matter what I get for each one of these. I get 28 for each one, no matter how I'm doing it. Okay. Of course, in general, I feel like it would probably be most appealing to use the function that we've computed rather than up here. So up here you're doing the same thing that you were doing right here, which is fine. I guess I'm not sure that either one of these is quicker than the other. All right. So as a note, f composed g of x is not the same as f times g of x. F times g of x is totally different. F times g of x means that I've got f of x times g of x. And just to show you that these are two different expressions, f of x is x squared minus 3x, g of x is 2x plus 1. And I get 2x cubed minus 5x squared minus 3x. Not the same as what I've got right here. Okay. The output values for one function are the new input values for another function. So just to give you a quick example, it's kind of like being at a car wash. Suppose that it costs $5 to get the car washed. Okay, and suppose that you've only got a $5 bill on you. Okay, you've got to go get a bunch of coins for change. So the $5 bill would have to be plugged into the car wash machine, and you get all these quarters. Okay, so the quarters are going to be used for the new function. Okay, so the output values for one function are going to be the new input values for another function. Okay, it's kind of like here. The output values for g of 3 are the new input values into f of x. Okay, suppose that we want to find g of f of x. Okay, whatever function is written second means I'm plugging that one into the one that's written first. So I need to find g of f of x. Well, f of x is given to me. That's x squared minus 3x. G of f of x is g of x squared minus 3x. G of x squared minus 3x, here's g of x, is 2 times x squared minus 3x plus 1. So that's 2x squared minus 6x plus 1. Now notice how g of f of x is not the same as f of g of x. Okay? Completely different. Now sometimes these do end up being the same. Sometimes. When that happens, it's special. Okay, and the function that we have is called the inverse of another function. We'll talk about inverses in the next section. But the point of that is to say that f composed g of x is related to an inverse function. Okay, let's find the domain of f composed g. So the first thing that we need to do is find the domain of g. Okay, because g is being plugged into x. Okay, and so I gotta know what I plug into g before I plug in those values into f composed g of f. Okay, compute f composed g of x and simplify. Determine the values for x. Okay, simplify as far as you can go. I'll say that now. Once you're in complete simplified form, determine the domain of f composed g. And if it's the answers from both 1 and 2, then you have the domain correct. So I've got to find the domain of g first, compute f composed g of x and simplify, determine the values of x, and then state the domain of f composed g. Okay, so let's take a look at this example. Suppose that f of x is 1 over x plus 2 and g of x is 4 over x minus 1. Okay, f composed g is f of g of x, which is equal to f of 4 divided by x minus 1. So I get, here's f, 1 over 4 over x minus 1 plus 2. Okay, 2 is the same as 2 times x minus 1 over x minus 1. Get my common denominator there. So I got 1 over 4 plus 2 minus 2. 4 minus 2 is 2. 2x plus 2 over x minus 1. When I flip that, I get x minus 1 divided by 2x plus 2. Okay, the domain of g is the set of all x such that x is not equal to 1. I can't divide by 1, so 1 is the number that I'm throwing away. The domain of f composed g, I start with the set of all x such that x is not equal to 1, which I've got. And then I'm going to look over here to what I've got circled, that's step 2, and see what I can't divide by. Well, if I have negative 2 plus 2, that's 0. I can't divide by 0. So I'm going to want to throw away negative 1 as well. So all in all, the domain of f composed g of this is the set of all x such that x is not equal to 1 and x is not equal to negative 1. Okay, g composed f of x is g of f of x, and So in the case of the domain, I guess I got to find the domain of f first, and then I compute g composed f and simplify, determine the values of x. The domain of g composed f will be the answers from 1 and 2. Okay, well, let me do that. G of f is 1 over x plus 2. G of 1 over x plus 2 means I plug in 1 over x plus 2. And for x, 1 over x plus 2 minus 1 gives me 4 divided by 1 over x plus 2 minus x plus 2 over x plus 2. Okay, and 4 is the same as 4 over 1. 1 minus x minus 2. 1 minus 2 is negative 1. I got the negative x there. Negative x minus 1 divided by x plus 2. And I'm going to flip that. So I get 4x plus 8 divided by 1 times negative x minus 1. Now the domain of f is the set of all x such that x is not equal to negative 2. The domain of g composed f would be the set of all x such that x is not equal to negative 2, and over here, I can't have negative 1 as a result. Otherwise, I'm dividing by 0. So the set of all x such that x is not equal to negative 2, and the set of all x such that x is not equal to negative 1 would be the domain of g composed f. Okay, and there's things like f composed f, g composed g, etc. So like, for example, f composed f means I've got to plug f of x into itself. F of x is 1 over x plus 2. So I got to plug that into f. F is 1 over x plus 2. Replace the x with 1 over x plus 2. So I get 1 over x plus 2 plus 2. 2 is the same as x plus 2 over x plus 2. So I got 1 over 2x plus 5 divided by x plus 2. And I can flip that. That's going to give me x plus 2 divided by 2x plus 5. Now the domain of f is the only thing that I'm working with here. The domain of f is all real numbers except for negative 2. Okay, so the domain of f composed f will be all real numbers except for negative 2, and what I've got circled here, x can't be negative 5 halves. Okay, so the domain of f is very important. In fact, if I were going to compute for example, say the amount of inches in, or the amount of inches, let's say, in a mile. Okay, well, I'm going to know how many inches are in a foot and how many feet are in the mile to know how many inches are in a mile. Okay, and I would get some expression representing how many inches are in a mile when I compute. All right. So the homework here is on page 263. Be sure to look at the problems there for homework when you get a chance.